So over the weekend, we did a Sudoku board challenge. It looks a little something like this, just to kind of get us started. Let's see if I can get a larger, slightly larger one. The game goes like this. You have the numbers 1 through 9, and you can't repeat it going. So I want to fill out this entire row so that it has the numbers 1 through 9. And those same, and this row will also have the numbers 1 through 9. And this box will have the numbers 1 through 9. And no individual number can be repeated going horizontally, vertically, or within this square. You don't have to worry about diagonals going front or back. It's just, if I have to have numbers 1 through 9 here, 1 through 9 here, 1 through 9 here, and nothing can repeat anywhere.
So can I ask something?
Sure.
Can I ask, so I created a set of criteria by which you can fill out the board, because there's only one solution no matter what. Like, if you stick a number anywhere, there's one solution after
Yep.
you stuck out one number.
Correct, yeah.
So it's pretty simple. If you can just deduce what you can't put or what can go somewhere, then you know how to draw the board. If you know how to draw the board, you can solve the puzzle, right? So
Ish, yeah.
Well, I got to the point where I kept blowing my stack because I couldn't recurse through the whole thing.
Sure.
To get through the whole thing. So
Yeah, so Sean was saying, because you already know what a bunch of the numbers are, like I have 1, 3, 5, 7, 8, and 9. I know that I need 2 somewhere, I need 4 somewhere, and I need 6 somewhere. And because I know I can just dumb it down to those 3 things, there's only one solution to every single Sudoku board. And that is true. There's only one place where every number can go that won't be repeated in any given horizontal, vertical, or 3 by 3. So you can just narrow it down to those particular numbers, put one of those numbers in, and just basically brute force the rest of it and just see it until it works. And that's kind of the solution that I have over here. I'm going to post this up for a little bit later. But seeing as nobody has actually done this yet, this might be a little too much. So this is the solution that I came up with. I wrote a bunch of little notes next to it just to help explain different parts. Let's just see if this runs at first. So I have r equals Sudoku.new. It takes in one particular giant string of numbers. Every place that it's a 0 right now is a space that we don't know the number yet. And then, so you can kind of see when I do r equals Sudoku.new with this particular string, I go all the way up to the top, and I'm initializing with board string. I know that I'm going to be doing a lot with board string a little bit later, so I immediately make an adder reader so that I don't have to keep typing this @ symbol in the front. So I initialize it with board string, and then I immediately tell it, once you create a new board string, print the board out. Jumping down to print board over here, my output is going to be an empty string to start with, and then down here I'm going to put the string out. So I'm going to split the board, this giant board string, into an individual character and an individual index. So I'm going to create a variable so I can count like a human being. I start counting at 1 rather than counting at 0, and then I'll change this a little bit later. First things first, I'm going to print dashes for every 9 by 3 section for visualization. So every 9 by 3, I'm going to print a bunch of dashes just so that you can see this, like this black line right here. So I'm basically saying if the index mod 27, so if it's like the 27th thing inside the string, at that point I'm just going to put a bunch of dashes. So because if it's 9 by 3, it's the 27th thing. So once I reach the 27th thing, I'm going to print out a whole bunch of lines. For the beginning board, right at the beginning, if you have a character equal to 0, remember 0 is that empty space, I'm going to replace it instead with just a space and print out all the other numbers. So every time that I see a 0, I'm going to replace it instead with this empty string. And then otherwise I'm going to just put the character in. After every 3rd and 6th character, I'm going to put some pipes in there. So every 3rd and 6th character, I'm going to put pipes so that you can kind of visualize it the way that you expect to.
Are you reading left to right?
I am reading left to right. Left to right.
Okay.
Yeah, completely left to right. And then, so every 3rd and 6th character, I'm going to put pipes. And then after every 9th character, I'm going to put a new line. So at the very beginning, I'm not going to solve it. I'm just going to show you what the printed board looks like. Ruby Sudoku.rb. When I print it out, it looks like this. So at the very beginning, I have those dashes, and then I have the 3x3 grid with the lines after every third and sixth thing. After every ninth thing, I put a new line just so that you can see what it more or less looks like right off the bat. So if I had to print this out onto a piece of paper, you can kind of see like, oh, this is a 3x3 grid, 3 blank 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 7 blank 6. I'm just printing it out to start with. When I do the solve method, this is where the main meat of everything comes into play. So let's take a look at where solve is. So I'm going to highlight it real quick, hit Command D, and I can see that def solve is here on line 11. So the first check that I do is basically if there are no zeros on the page, like then if the board string has no more zeros, then I'm going to return true and I'm done. Because at that point, I know that I have filled in every single space. So that's the first check that I do, because I'm recursively calling solve over and over and over again until there are no more zeros. Otherwise, I'm going to find the next missing number. So I'm going literally one by one, saying like 3, all right, that one's full. I get to the next 0. Once I get to the next 0, I need to basically check like what are the numbers that I can put in its place, and then can I solve it? So I have this next missing number. I'm basically going to brute force every single possible number. There's probably, I don't know, millions, hundreds of thousands, if not millions of possible permutations. And that's something a human will take a while to do. That's why Sudoku in general takes a while until you get good at it. The really hard ones will take a very, very long time. But a computer can do it much faster. The computer is stupid most of the time, but it is faster than you. So I'm literally just going to brute force against every single number. I set my next missing number as 1 and test it against every single check. If it pans out, then we know we have the right number. If not, we go to the next number. So every single 0, I go literally 1 through 9. This is not the optimal way of doing it. If I go 1 through 9, basically see like, does this work, does this work, does this work, does this work? And I just keep going until it always works. If it's a legitimate board with that possible move, then we recursively call this method solve again until there is no more zeros. And the big checks that I have is I have a method called legitimate board. So I try to do as small methods as possible, but that only do one thing. So legitimate board with a question mark will return me true or false. That's pretty much it. I'm just checking, is this something that's legit? So what I've got here is I pass in the index of the number, and I basically see, is it a legitimate row? Like if I go straight across, are there any repeated numbers? Then I see, is it a legitimate column? Wait, does this column go this way or row? It doesn't matter. I check the column,
Row.
I check the row, and then I check the column, and then I check the legitimate grid. And that's all pretty much that I do. Is it legitimate going this way, and the 3x3? Now the big thing, and here's all of the code that I have here. So legitimate row, column, and grid. I have a valid thing over here, which basically says, does the index that I'm passing in not equal the index of the number, and does the number equal this particular board string? All this to say, I'm basically checking going vertically, horizontally, and inside the grid, are there any repeated things? That's pretty much what I'm checking inside of here. And in the end, if the numbers that I pass in 1 through 9 are possible, it comes back up to the board string, there's no more zeros, and it returns true out to the board. So this first one, I'm just going to do solve and then print the board. So you can kind of see every single step that it's taking. So here's a visualization of what's actually happening underneath the hood. Start here, and oh, geez, okay, I guess it's done that fast. And I think there were 50 of these right over here. So they start off really easy, and then they end much more. It's much more difficult. There's much more zeros at the end than there were at the very beginning. So I'm going to read through each one of these and try to solve all 50 of them. They start from really easy going to really hard. So let's see.
Can I ask a question?
Sure.
So when you start this, you're just going to the first spot first.
Literally the first spot.
And let's say it just picks 1, and that happens to work. Because none of the other things are filled in yet.
Yep.
So 1 is likely to work.
Sure.
That's not necessarily the right number for that spot. And you're going to figure that out later.
Yep.
But how does it come back and figure out later?
Sure, Sean.
It recursively is false, so it'll call itself again and try the next thing.
Yep.
Like it'll just backtrack.
Yeah, it goes back.
It'll go and then it'll backtrack and it'll go and it'll just keep sweeping back and forth until it's done.
Hmm.
Yeah. It really helps to look at a call stack and see how that works.
Okay.
Let's read all of these boards really fast, and we will see all of these in action. So I'm going to call each individual one. So we're going to cover this tomorrow, but I'm going to read each line here, and I'm going to print the solution. So we'll cover exactly the code that I'm writing. I'm going to do csv.read. I think it's called sample. What is this file called on the left? Sample Sudoku board inputs.csv. And then let's just put a binding pry here for now so that we know what file looks like. Require pry at the very top. And let's run this. Uninitialized constant CSV. So you can kind of see over here, I'm requiring the CSV class, but there's no CSV class inside of here. Since it's a library like binding pry, all I've got to do is add it up to the top, require CSV, and let's run this now. So let's take a look at what a file looks like. A file looks like it's a multi-dimensional array, and each one of those arrays has one element inside of it. So I have a multi-dimensional array, and I probably want to iterate over every one of them. And because I just want the string inside of each one, what's the method for me to take a multi-dimensional array, which is basically an array of arrays, and make it into one?
Two sets of brackets.
What's that? I could do two sets of brackets, but the thing I'm looking for is just flatten. If I do file.flatten, before I had a multi-dimensional array, now I have an array with just a bunch of strings inside of it. But I could do double bracket as well. So I'm going to do dot flatten.
Is there a concat thing?
It's the same thing. So I'm going to read file, each do string, and I'm going to iterate over each one of these strings. All right, I think that should do it. I'm going to exit here, and we're going to take a look at see all of these run. So it goes through each individual one. It prints out the initial board, and then it solves the board, and then we'll print that out. You can kind of see it's kind of hanging on one. I'm not really sure. Oh, there it is. So you can kind of see even for the computer, it takes it 4 or 5 seconds to run through every single possible combination in the entire world. You can kind of see it's printing out this particular board. There are more empty spaces than before, and once we get closer and closer to the bottom, you'll see it takes much longer than the very beginning ones. Sean?
I was going to say, you can essentially you just have one character to do it. Take a long time.
Yeah. Yeah, what I'll say about group projects, I did not expect none of the groups. I did not expect 0 groups to complete this weekend. Group projects are fairly difficult. It's challenging to distribute work among different people, and that was like the main challenge of the exercise for this weekend was like, how do you distribute a very large project into individual people, but did not expect 0 people to finish the project. So I will save, the next time we do a group project, I'll expect everyone to actually participate, and then we can cover what it was like on Monday, on that day. Kristen?
Do you have any recommendations? In our particular situation, it's not that we weren't, because we had discussed working together.
Mm-hmm.
Because by the time we all agreed to work together, one of the person who was the most capable in the group got impatient. Do you have any recommendations for that? Or?
So the question was if one person kind of takes over and does the entire thing on their own. Is that more or less? Yeah. That is not the first time that's happened. First question is, why did that happen? Like, why did it take you guys so long to get the group together? Right? Because somebody got impatient for a reason. If it was an unreasonable amount of time, oh, you didn't do it in the next 5 minutes, and I did it, that's something different. But you told me it was on Sunday that he just did it.
Oh, he did it on Saturday.
Okay. So why? So on Friday, why was nobody determining, like, let's meet up tomorrow at X time?
Well, he left early because he was sick.
Yeah.
And then,
So why didn't no one slack him?
And then what's that?
So why didn't no one slack him? I'm not trying to be difficult. I'm just saying, like, these are the questions that need to be asked.
No, I mean, I can't speak for everybody, but I had a visitor come in town, so I entertained
Sure.
Friday and Saturday.
Sure.
So that was my constellation was to get together on Sunday, and then Sunday rolled around and he already done it. So.
Yeah. Did you let everyone know that at the beginning?
I relayed it to Conway. I don't know if I relayed. I think I talked to you before I left.
Yeah. I knew it was going to be Sunday. I just waited for it.
Okay. Sean?
I mean, I think like whatever the expectation is, and make sure I say this the right way. Sometimes it's unrealistic if it's on a weekend and you have like things you can take care of.
Yeah, that's not false. We also agreed that we would all be here. So when somebody like Mark tells me that, hey, I waited for 30 minutes and nobody was there, that's a waste of his time, that he came down on a Saturday and said he would be here and 0 people were here.
We didn't shut the
Yeah. So if his scheduled hours are 11 to 1, he says, I'm going to give up my Saturdays to help out and I'm going to come downtown. I don't even know where he lives. And then nobody's here. It's kind of insulting to him. So he's kind of like, should I come back? And he's saying that like earnestly, like, should I come back? Or am I useful on Saturdays? I was like, I'll see if they want you today. So do you want Mark to come back on Saturdays?
Yes, I know for me, the last Saturday I spent all weekend here. This
Cool.
Saturday we just happened to be.
That's fine. And it's no one's saying like, hey, Mark, like, just tell him like, we'll be in a little bit later. Can you come in a little later or something like that? But he came in here. He was waiting for 30 minutes outside. He got inside. Nobody was here. And then he left.
I think you probably just started from one Friday or Saturday, so who's confirming who's coming in.
Yeah,
So
something between the whole team here. All right, with that, I'm going to push this one up so you can have access to it. And then we'll cover some class variable stuff. Git status. Say gets. So I have 2 changes right over here. I have the regular file and the spec file. I'm going to do git add, git commit -m, John's solution for Foxtrot, and git push origin John's solution Foxtrot. There are always people, Tristan, who are going to just kind of take over, but there's a reason why they took over.
He's very good. He did it. I think he did it in like 3 hours. So.
Yeah.
I don't know. I mean, paired with someone like John, my contribution was pretty heavy. But no, I mean, he didn't. It wasn't like I think it was John being John. I don't think he just like saw opportunity.
Sure.
He has the ability to do that. That's awesome.
Yeah, he's really good. He's been my partner a couple of times. He's really good.
Yep.
But I do have a question as far as approaching problems like this. I guess it would I guess it would have helped more if I like understood Sudoku, but like even just knowing okay, this is how you have to check it, you just have to check it. Like, because I guess you could have done that like you said, you could have done it with the for loop instead of doing it recursively. But what was your thought process in like approaching this problem? Like, okay, like, I'm not going to use like an array, so to speak, but I'm going to like just tell like to use every solution, like, like I wouldn't even have thought to kind of like, do every solution. I don't even know how I would have tried to tell.
Yeah, so I mean, on Friday, the reason why I was like, make sure you pseudocode everything up front is I gave everyone an easy Sudoku board to solve. And this easy Sudoku board, like there's only one possible solution, so you would have to figure it out first. And then you can translate the steps that you took into code. The reason I chose an array was because I can easily, I chose a string. You can do a string or an array in this instance because you can easily index any one of these things. And you can easily index any one of these things and easily index any one of these things. So it's like this particular this particular number is the 1, 2, 3, 4, 5, 6, 7, eighth thing in the row. Because it's the eighth thing in the row, it's at index 7. So you can, and that's what, but I also added 1 to each one because I count like a human being and not like a robot. So I was like, I can always easily access this particular number and fill it in with something else. And I can always easily get to this one and fill it in with something else as well. Yep.
I feel like the troubleshooting that you have to do is just looking at the spec and then looking at exactly, from like, because I asked you with like, okay, is it an array of arrays? Because it looks like it's just one long number. And how am I supposed to like chop it up? Like you kind of have to know what's possible, what the spec is.
Yep.
Like that spec for the thing, like it told you literally what you're going to take in. Mm-hmm. So knowing that, you kind of have to know how you're going to display it. So I was like, okay, wait, if I'm going to chop this up into an array of arrays, it's probably not going to come out the way it's intended as a single string. So I asked John, I was just like, is this intended to be this or is it intended to be that? And that gave me like the clue on like, oh, I know which way I feel this now. But you have to be like, I would say hypercritical of the spec. That's all.
All right, let's talk about object orientation because I think that's a good place to be. Address.rb. Let's talk about an address. What does every single address have?
A street.
Okay, wait, hold on. Initialize. And okay. It has a, let's say you're writing a letter to somebody. So what does every single address on a letter have?
Name.
First name, last name, what else?
The street address.
Street 1, right? Like, because they usually call it street 1, and then street 2, perhaps. What else?
City.
City.
State.
Yep.
Zip code.
Zip code. Now, every single address, every single address, when I create an instance of it, is going to have a first name, last name, street 1, street 2, city, state, and zip code. So down over here, I'm going to do maybe address as a local variable equals address.new. And let's say that I'm going to write to Rod here at Code Platoon. So Rod Levy, 73 West Monroe Street, Suite 303, Chicago, Illinois, 60603. What do you notice right away about, does anything stand out to you about what I just did?
Better pattern, and your initialize the same pattern and your new address?
Yeah, pretty much. So the main thing is every single thing that I type in has to match up at every single given point. So let's see if this works. So at first name equals first name, at last name equals last name.
You can have default parameters though.
I can. That is not where I'm going with this, but that is also true. Street 1, street 2, at city equals city, at state equals state, at zip code equals zip code. So we have local variables. Local variables, first things first, like if I have some random variable, some random variable only lives within the context of this particular method between lines 2 and through line 11. If I have another thing where it's like print address nicely, I cannot use some random variable inside of here. Like this is not going to work. So again, I have an address class initialized with all the things that I need. I have some random local variable here on line 3, and I'm going to try to call it here on line 4. This won't work because this is a local variable. It only exists within lines 2 through 11 right over here. So if I run this, I run list everything out. What the heck? Did I save this in the wrong place? Yes, I did. Save as. Let's put this in desktop, put in variable examples. I run ruby address.rb. It blows up because there's an undefined local variable or some method, some random variable. Doesn't exist inside of lines 13 through 15. So local variables are the bread and butter of your like life. It's going to be just within the scope that you defined it. Let's say if I wanted to print out like the first name, last name, street 1, street 2, city, state, and zip code. How would I do that? How would I print that out nicely? Like let's create a string and then we'll try to print it out nicely. So I'll get you started. I'm gonna have an output equals an empty string, and somewhere on the bottom I'm gonna return the output.
We could do output plus equals first name. Yep.
Mm-hmm.
Last name.
Okay. I'm just going to put a new line over here.
Yeah.
All right. I'm going to do the same thing a few times. So for street 1, if I'm not mistaken, and then you have street 2 right underneath it, or do you put them all on the same line?
No, I think all on the same line.
Okay. I'm not sure. So
yeah.
Street 2.
Because if you printed a getter, you would put that, and you want to
Yeah, we'll get to that. Let's just get this to work, and then we'll jump into getters. So we have first name, last name, street 1, street 2, city, state. Is it city, comma state?
Yep.
At state, and then zip code. All right. So let's see if this works now. So again, we have a class called address, and it's something that it's a noun. It has attributes like a first name, last name, street 1, street 2, and it has abilities that it can do. So this address can print itself nicely. Like, so I can print address nicely, and based on the input that you give it, I'm going to create a string and put it out to the screen. So let's see if this works. Ruby address. It's not looking too good. I have Rod Levy, \n, \n. Okay, I'm not really pleased with that. Maybe we will just do a puts output. All right, so when I puts it out to the screen, it looks the way that I expect, which is Rod Levy, 73 West Monroe, Suite 303, Chicago, Illinois, 60603. The reason why we're able to use these particular, why are we able to use these particular variables?
Because we are telling it that it's a global variable, but or not a global variable, but an instant variable by putting the @ symbol.
Yep. So we have two types of variables. Output, right, is a local variable. It exists within print address nicely between lines 12 and 20. We have an @ symbol in the front of this @first name, and that's an instance variable. We declared it on line 3 here, right when we created the class. So now every single method has the ability to use @first name and @last name. But the @ symbol kind of sucks, like Sean said. So Sean, how would you make this look a little nicer?
Well, here's something that happened to me when I refactored the assessment.
Mm-hmm.
Like I started realizing, like once I called the whatever instance, the initial, what do you call it? The instance variable.
Yeah.
Once I called it and defined it once and cached it into a variable, I could use that variable inside of that thing and then pass it to other things without calling the @ symbol again. Do you know what I'm saying?
No.
So like, say I created a method and I said this or whatever, you know, and then whatever's coming out of there can just be called whatever.
Correct.
And at that point, I'm good. So I could create one method, like if you wanted to, that was like @ equals this, and you could just do that across the board, and then you could pull from those if you wanted to, or push them anywhere.
I could, but that's not answering my question here. How do I make these, instead of doing @ in the front, how do I change them to look a little nicer?
Add a reader.
Add a reader.
Yeah.
The answer, I don't know the answer to your question without looking at the code. That's all. First name, last name, street 1, street 2. It doesn't matter the order. They're all here. City, state, and zip code. So what I have here is I've made all of these instance variables into attr readers. And attr reader basically means attribute reader. I'm going to get some sort of attribute from this particular object, specifically the first name, last name, street 2, street 1, city, state, all that kind of stuff. What this gives me the ability to do is, instead of writing at in front of everything, I can actually just get rid of all of them and just call it as a method. So first name, when I call it as a method, remember, first name doesn't exist within lines 14 through 22. Like, there's no method or variable called first name. But because I created it as an attr reader, it's going to look here. Is there anything inside of here that says first name? If not, I'm going to go up to the instance variable level, so the attr reader level, and say, is there a first name, a last name, street 1, street 2? It says, okay, there's a first name. Let's find wherever that was declared and return that particular variable out. So let's see. Does this return me the exact same thing? Rod Levy, 73 West Monroe, everything looks the same. If I were to overwrite first name here, first name equals something else. Let's see what we get. Looks like the variable has the local variable has a higher weight than the instance variable. So because I overwrote first name here, when I call first name here down on line 17, it's actually something else rather than the original, which was passed in as Rod. So we have instance variables, the things that are able to be used within by having an @ sign here. I'm able to pass it around everywhere inside the instance of the class. And I have local variables. Local variables are just like scoped to that particular method.
And you can't stick a local variable outside of that.
I cannot just stick a local variable like something here.
Go for it.
Yes, that will definitely not work. So all of your classes are going to have different methods. Those methods are going to do things. You cannot just simply have random variables sitting out here in no man's land. They have to go inside of methods. Now, one thing I wanted to point out before I move any further is you can kind of see that I have to pass these in exact order in order for it to work every single time. And that's a little bit brittle, because what if somebody doesn't have a street number 2? Like, my parents live at 123 Main Street or something like that. There's no apartment, it's just a house right there. There's no unit number, there's no subdivision or anything like that. It's just, you know, what if we were just at 73 West Monroe Street? So how do we default an argument to equal nothing? Empty string. So where does that go? I'm going to default it to go
Inside the initialize.
inside the initialize. So right now it's expecting us to pass in every single one of these things. If I pass it in as like street number 2 equals empty string, if I pass in nothing for street number 2, then it'll automatically default to this thing right over here. So if I remove this, technically I should be able to get away with street number 2 being an empty string, right?
But it has to be at the very end, right?
What's that?
You have to build from the end on the back.
I have to build from the end on back. So you mean if it's the last thing?
Yeah,
So maybe a street?
Yeah.
Yeah.
I think it'll work then, but it won't work if you do it.
Sure.
Anymore,
So-
because how would it know?
Exactly. Let's try this out right now. Let's see what we get. So again, I've taken away suite 303, and I'm just going to have it hard-coded to nothing. Let's see what happens. What do we get? So when I Ruby address out, I get Rod Levy, 73 West Monroe, Chicago, Illinois, 60603. It actually strangely knows that I don't need this. Because this is already defaulted here, it knows that because I've provided it fewer things, that the street 2 is going to be an empty string at that particular point. This is not always reliable though, right? Like, you can kind of see it's already pretty brittle. What if I mix up first and last name by accident, or I flip around the zip code because I have an incompetent intern or something like that? I throw Illinois here, and I flip around the city and the state by accident. So now my address looks a little something. Oh, now it's really broken. Initialize wrong number of arguments on line 4. I was given 5, but I expected 6 to 7. 1, 2, 3, 4, 5, 6. Did I forget? Oh, I forgot to put a comma on the outside. My mistake. So now my address looks completely wrong. I got Rod Levy at 73 West Monroe Street, no suite number, Illinois, Chicago 60603. So even by you can kind of see it's pretty brittle by just having everything expected in one specific order. So has anyone seen a way to kind of get around this?
I think validation.
You can have validations, or I'm going to pass it in actually as one giant hash. Because you can kind of think of because hashes are not in order, as long as it has a specific key, you can pass it in whatever order that you want. It's not reliant on first name being first, last name being second, street one being third, or anything of that nature. So what I'm going to do is I'm going to create a hash, CP address equals a giant hash. I'm going to do first name goes to Rod, last name goes to Levy, and so on and so forth. Give me a second. Bear with me as I get this done. Street one. So I've changed a few things. The first things first is I just created a hash called CP address with all of the attributes that I need. Then I can just pass in the entire hash inside of address. And at this particular point, I'm going to start looking for keys rather than specific spaces. So address hash. Let's see if this prints out everything like I expect. So before it looked a little messy. I'm going to run it again. We can see Rod Levy, 73 West Monroe, Chicago, Illinois. So my general rule of thumb is when you are passing in more than 3 arguments, I would generally push it into a hash. And the reason behind that is, like we saw a little bit earlier, if you mixed up the state and the city by accident, then it prints out incorrectly. If you messed up the zip code and the first name or something like that, then it'll all be jumbled up because you're relying on it to be in a very specific order every single time. And if you're expecting 7 things to be in order every single time, you're going to be in a little bit of trouble. So because I have 1, 2, 3, 4, 5, 6, 7, I have 7 things I'm expecting. If I pass it in as a hash, I'm looking specifically for first name every single time. It doesn't matter what the order is. I can move this first name all the way down to the bottom. I can move street 2 to the front. I can move zip code all the way up here, add a comma. I can pass it as in order or as out of order as I like. It doesn't matter because it's a hash. I print the address nicely. It still comes out exactly the same. Any questions so far?
So, oh, I see. Because you're creating it. You're creating a hash there. You're actually creating the keys there.
Yes.
As you're passing them.
Yep.
Got it.
So this is one reliable way of doing it rather than having like 7 things in a row.
Is that standard? Is that like how
Yes.
people-
Yeah. That's generally how people do it. So if you have an initialize with 17 things in a row, if you mess up one of those 17 things, your whole program breaks. That's the idea behind passing it as a hash rather than, so you're looking at by the key rather than relying on a specific order. Is the thing I passed in at number 5 actually correct? That's a small user thing. All right, so I want to talk about types of Ruby variables, and then we'll be done for today. So we talked about local variables. Local variables begin with just lowercase letters like this, and its scope is only within its immediate vicinity. So it's only available between lines 14 and 22 over here. Its output will not live anywhere else. Then we have instance variables with the @ sign in the front, which is available to any specific instance of this class. So I can use first name and last name because I put them as readers. And once I declare them, I can read them anywhere else. There's something called class variables, which I'm going to show you right over here in this example called Ghost. let's have this little bit of code, and can somebody basically run me through this? James, can you run me through this of what you see so far?
See, double at, that makes it a class variable and sets to 0.
Mm-hmm.
You've got a header reader for variable name,
Mm-hmm.
initialized name var, and so every time that a ghost is created, you're going to count up 1, the ghost in the world counter.
Mm-hmm.
And the name add names equal name variable. And then you've got another method, how many ghosts, which calls up the ghost variable. Then you've created an object, ghost object,
Sure.
on at the bottom there.
Yeah, so I have G, local variable, to this particular file, ghost.new with John. So my name for this particular ghost can be John. This double at in the front stands for class variables. And class variables are different from instance variables in that they're available to the entire class in any method across all instances. So it's having like one master, like, anybody watch Star Wars? I don't know, big Star Wars fans? Okay. So like in the really bad prequels in the second one, they executed some order that every single like stormtrooper knew to kill a bunch of Jedi, right? It was like order 66. It was basically like, you can think of a class variable as like, it was programmed into every single one of their brains. And then at one point they can just turn it on and then they would kill all the Jedi. So you can kind of think of class variables as the stormtroopers that killed all the Jedi in episode number 2. Yeah.
So as it updates in 1,
Mm-hmm.
they all get updated?
Exactly.
across everything?
Yep. So let's say I have G equals ghost.new John, and I'm just going to do P G dot how many ghosts. So G is this particular instance. It's just John. I'm going to print how many ghosts, and I expect there to be probably 1, right? 1. Now, when let's say I create another ghost, so we'll call this P equals ghost.new, and we'll call it Peter. Oops, let's say Pete equals ghost.new Peter, and then I do P G dot Pete dot how many ghosts. What do you expect this to be? This was 1, and this was 2. 1 and 2. But now let's go back to how many ghosts were for G number 1. Before it was supposed to be just 1 because that's in a particular instance of this. But when I change the number of ghosts for the entire class, it actually changes for the original as well. So 1, 2, and 2. And you can kind of see the original ghost is relying on the number of ghosts in the world to be just 1. And because there was another ghost created, it actually overwrote the class variable called ghosts in the world from 1 to 2. So your data is not really as secure as it could be because you're updating every other instance of that. Yeah.
Do you use these often?
No, these are used actually very, very infrequently. I just want to make sure that everyone knows what they are. So again, class variables begin with the double at in the front. They're available to the entire class in every method across every instance. So it's pretty dangerous because if you change it once, it could change everywhere and have pretty catastrophic implications. Class variables raise an error if they're read before they're created, and they can just generally cause a lot of issues down the road because you're updating every method, every instance of that method, and every method and every instance of the class. So if you change one thing one place, it could change across 10,000 other records by accident.
There's something like that in JavaScript. Very typical inheriting. You change a code, it kind of breaks everything.
Yep. Yeah. So you want to avoid that. It's a similar concept for that one for sure. So class variables, again, you can use it in every single method, in every single instance of every single class. So you don't want to use it as much as possible. The two main things you want to use are instance variables because it's scoped just to this particular instance that you created, and local ones. Those are the ones you're going to be using the most often. The final one is called a global variable. Global variables are the most dangerous. So global variables have a $ in the front. They're available to the entire application. So not only is it available just to your class, every instance of your class, and every method within your class is across the entire application. So I could say like basically like admin equals true by accident, and then I can have some banking software and I can steal everyone's money. Essentially, that's what you're looking for. So the $ in the front, whenever I see it, I always know that instantly there's probably a better way to do it, because there's very rare cases where you're going to want to have a global variable across the entire application. And your applications don't make much sense right now because it's just one class. But when we start doing things like this afternoon's challenges with Apple Tree and bowling and things like that, you're not going to want to have global variables at all. Any questions? So we covered local, instance, class, and global variables.
Have you ever, this is totally related, but no one's gonna get it but you.
Sure.
Like, have you ever created objects that don't keep their state? They just automatically pass their state to like a database or something? Does that ever happen?
Yes, but not very frequently, because you usually want to do something with those attributes inside the state. Like you want to take some actions to alter the state before it gets sent to the database. All right, so let's take a look at the challenges that we've got for today. Again, we changed Monday, Wednesday, Friday to being solo days, and then Tuesday, Thursday to be pairing days, just for people to have enough time. So week 3, day 1. There's not a ton of challenges anymore, but the challenges are longer. So there's not 6 things to finish in one day. There's only 1 or 2. There's apple trees and there's bowling. Apple trees is a very, very meta kind of, why is this not opening a new tab? Oh, crap. Well, apple trees is a very, very meta kind of concept. It's basically, I have a bunch of apple trees, and each individual apple tree can spawn many apple instances. And then you can have some fun with that one. The more concrete one is bowling. I'm going to create an object-oriented game to basically initialize 2 players, have them bowl, and then you keep track of their score and print it back out. And that's pretty much all we had for today. Are there any questions on anything? Yeah, Tristan.
We're still hopping back in between JavaScript and Ruby?
Nope, this is all going to be in OO, object orientation, and the only language we know object orientation is in Ruby. Yeah. So JavaScript will kind of take a little back burner for a few weeks before we jump back into it in week 5. So this week is going to be all Ruby. Next week will be half SQL and Ruby, half SQL, half Ruby, and then the week after that we'll finally get back into a little bit of JavaScript for
I'm
fun.
actually pretty excited about that. I could focus on one.
Yeah, sounds
as
good.
opposed to trying to do 2 at once.